Zurich offers a high quality of life. Situated on Lake Zurich, the Limmat and Sill rivers, Zurich is a city on water. Those who live in Zurich are accustomed to the excellent quality of its bodies of water. This water quality contributes to Zurich's quality of life and is constantly monitored. Nevertheless, Zurich also consumes water. RZ Entsorgung und Recycling Zurich treats the city's wastewater in the Werdhölzli sewage treatment plant. The plant is the largest and among the most modern in Switzerland. After heavy rainfalls, the flow in the plant rises to 6 cubic meters, or 35 filled bathtubs per second. This adds up to 70 to 80 million cubic meters of wastewater per year, which nearly equals the load of a supertanker per day. The water is in the plant for around 19 hours, where it undergoes various treatment stages. Mechanical treatment, biological treatment, sedimentation, ozonation, and in the end, filtration. The sewage treatment plant's capacity is limited. If, in cases of extreme rainfall, too much wastewater reaches the plant, some of it is routed to huge underground rainwater tanks and stored until after the rain stops. While the rainwater is in the tanks, suspended solids settle to the bottom. Once the tanks are empty again following heavy rainfall, they are flushed out with a gush of water. If even these basins are filled up in the case of extreme rainfall, then additional wastewater consisting nearly exclusively of rainwater overflows directly into the Limmat. Under normal conditions, the rainwater is pumped from the tanks back to the sewage treatment plant cycle. The treatment process begins here with the mechanical treatment. This takes place in the screening building, in the oil and sand trap, and in the primary clarifiers. Coarse materials such as paper and feces are removed in the screening building. Whether everything has intentionally ended up in the wastewater is questionable in some cases. After screening, the water flows through the oil and sand trap. In the aerated section, the water density decreases. Sand settles down to the bottom of the tank and is then removed. In the calm, non-aerated section, oil and grease float to the top and are skimmed off. Free of solid substances, sand, oils and grease, the water now flows to the primary clarifiers. The flow rate is very low in these tanks. This enables suspended solids to settle to the bottom as sludge. This sludge and water now undergo further treatment in separate processes. We'll first observe what happens with the sludge. The sludge is pumped from the primary clarifiers to the first treatment step, the prethickening. The sludge is still very fluid, consisting of around 98% water. The sludge remains for around 10 hours in the prethickening tanks, where it is slowly mixed. Suspended particles settle to the bottom in the process, while so-called supernatant collects in the upper section of the tanks. This supernatant flows back into the primary clarifiers. The thickened sludge from the bottom of the tanks is pumped to the primary digestion tanks for the second treatment step. In the primary digestion tanks, the sludge is heated up to 38 degrees and fermented for around 3 weeks. During fermentation, microorganisms break down organic substances in the sludge into methane gas, carbon dioxide, and water. The sludge is all the while mixed with pumps by injecting compressed gas. The produced methane gas is purified and used to heat up to 5,000 homes in Zurich. After 3 weeks in the primary digestion chamber, the sludge continues to the next treatment step, the secondary digestion. Here, microorganisms further break down organic substances in the sludge. The sludge still contains around 97% water and is now pumped into the sludge dewatering facility. The sludge dewatering centrifuges rotate the sludge around 50 times per second. The centrifugal forces press the water out of the sludge. The share of solid material within the sludge increases from 3 to 30%. It is no longer liquid and is transported away along a screw conveyor. This is how it reaches the sludge incineration plant. It is incinerated in a top modern plant along with the sludge delivered by truck from all other sewage treatment plants in the canton. From the facility's sludge bunkers, the sludge is first lifted with a crane and additional screw conveyors to a disc dryer. There it is dried with hot rotating discs to the point where it self-incinerates. The sludge then reaches the fluidized bed incinerator. This incinerator burns around 3 kilograms of sludge per second. The entire sewage treatment plant is heated with the incineration heat. The flue gas is cleaned in a multi-stage facility and is ultimately far below the legal limits. The ash is collected in silos and transported away several times a day for depositing. The central incineration solely from sludge will in future enable the recovery of phosphorus from the ash, a raw material growing scarcer around the world. The entire sewage treatment plant can be controlled from the central control room. All processes in the plant are monitored around the clock. The crew in charge can intervene in all processes if needed. The Verdhelsley sewage treatment plant is built on top of an aquifer. That is why an elevated service corridor connects all parts of the plant. Along this aqueduct run cables and supply lines, including data cables, water and sludge pipes, and the power supply. The aqueduct's easy accessibility facilitates optimal maintenance. Now let's take a look at the further treatment of the wastewater. After the sludge is separated from the wastewater in the primary clarifiers, it flows through the underground channels to the biological treatment. Since the tanks are considerably higher than the channels, pumps raise the water up 5 meters in height, at peak times up to 6 cubic meters of water per second. There are always 2 tanks connected in a so-called lane for the biological treatment. The water flows slowly through the tanks. In the end, the water flows to one of the tanks that are part of the lane. Then the water flows to the secondary clarifiers. During biological treatment, microorganisms clean the water. While one tank in each lane is fed with water, the other is aerated and mixed. Ammonium is converted to nitrate with oxygen here. The functions of the respective tanks then switch. In the tank that is no longer aerated, without oxygen, the nitrate is converted to elementary nitrogen. By switching the tanks, the plant can flexibly react to different rates of wastewater flows and loads. Impellers and over 18,000 diffusers are installed in the tanks for mixing and aerating the wastewater. The required air pressure is created by turbo blowers beneath the tanks. A constantly aerated section is located at the end of each lane. Ferrous salts are added to the water here. Phosphorus is thereby precipitated out of the water. The plant requires a truckload of salt around every 3 days. From the biological treatment, the water flows to the secondary clarifiers. An extremely slow cross-current flows through the secondary clarifiers. The microorganisms in the activated sludge, along with the phosphorus that is precipitated during biological treatment and is bound to the sludge, settle evenly to the bottom along the entire length of the tank. The sludge is removed by suction scrapers and pumped back to the biological treatment. Because the microorganisms constantly replicate, part of the activated sludge is conveyed back to the primary clarifiers and disposed of with the sludge treatment. The water now flows through the penultimate step, the ozonation. Ozone gas is added to the water in a completely dense tank here. Ozone is chemically very reactive and splits micropollutants such as medicine residues, pesticides and hormones contained in the water. The ozone is dosed so that it completely reacts in the water while flowing through the tank. Any residual ozone rising from the water is captured in the completely sealed tank and destroyed. The ozone is produced from pure oxygen using artificial lightning. The pure oxygen is produced from the surrounding air. Liquid oxygen for 3 operating days is also stored at the plant. Following ozonation, the water flows to its final treatment stage, filtration. Here in the 18 filter basins, it is cleaned in the same way as groundwater in nature. It seeps through a layer of sand. In this way, the smallest suspended particles and remaining activated sludge residues are filtered out. Bacteria in the sand also break down the molecules that were split by the ozone. Because the sand filters clog over time, they are backwashed upstream every 2 days. The water feed is stopped to enable this. Then the filters are backwashed from below with air and water. The water used for cleaning primarily contains residues for activated sludge and flows back to the mechanical treatment. With filtration, the treatment of Zurich's wastewater is complete. The quality of this end product of the sewage treatment is constantly monitored and significantly exceeds the legal requirements. The clean water flows into the Limmat River and thus back into the natural water cycle. Entsorgung and Recycling Zurich thus carries on the natural cycle and protects the habitat of plants, animals and people. In this way, ERZ promotes the city's quality of life and makes an important contribution to the clean future of Zurich.